Chapter 15, Practical Electricity. So first, let's look at the heating elements. So heating elements are usually made of long, thin wires of nickel chrome or iron chromium aluminum alloys. If you can remember the formula, R equals to rho L over A. If you have long wires and you have thin wires, which means the area is small, you will have high resistance. So such heating elements are able to withstand high temperatures and have high electrical resistance, R, and high resistivity. When we pass electric current through these heating elements, we want their temperature to rise rapidly so that we can convert electrical energy into thermal energy. Yeah, symbol, it's 4 squares side by side. So these heating elements are actually used in examples like electric kettle, where we will try to convert the electrical energy to thermal energy. Another example is a conventional oven. So as you remember, this is the heating element. As you heat up the air, hot air rises because it expands and is less dense. Cold air sinks. This results in a conventional current being formed. Another example is electrical heaters in winter countries. We also convert electricity to thermal energy. One other example is the light bulb, where we run current through this tungsten wire. This will produce light energy as well as thermal energy in the form of infrared wave. Okay, let's look at a new formula that we have to learn for this chapter. So P, power, is equals to VI. The units for voltage is capital V, current, ampere. But for power is watt, capital W. So let's leverage on a previous equation that we have learned. Power is equals to work done over time or energy over time. Combining these two formulas together, we will actually get VI equals to E over T. E, energy, is equals to VIT. And that is the formula you need to use for today. Okay. So let's look at how we calculate the cost of electricity. Cost is equals to energy use times cost per kilowatt, capital W, hours. Means it's the amount of electricity used per hour. Next, let's look at the dangers of electricity. If you have a damaged insulation like this, it can create or can cause electric shock when it's touched, because the current will run through your body to the ground. When you have a lot of daisy chains or a lot of multi-plugs, okay, this may cause overheating and electric fires, because you are actually overloading the power socket. As you plug more devices in or appliances in one socket, it actually causes a large current to flow through the wires and overload the system. Same thing, if you place exposed wires or even these daisy chains in the toilet, it's actually providing a conducting path for currents and can lead to electric shocks, because water, okay, will cause the resistance of the body to be lowered drastically. So water will cause resistance to decrease. Okay, another safety features in homes is actually the circuit breaker. Okay, you will have seen this around school as well as in your homes. Okay, so circuit breakers are safety devices that can switch off the electric supply when a large current flows through it. So circuit breakers are also connected to live wire, of course, because it's where the current comes from, and it can be reset easily. So usually when there's a large current flowing through, the switch will flip and the circuit breaker will cut the electricity off. So what you can easily do is to reset by flipping the switch. Another method to protect us or protect the appliances from overheating and limiting current is fuse. Remember, the unit symbol looks like this, square block with a line through it. So same thing, fuse are connected to a live wire, but they have to be replaced after it is blown. A large current will go through this thin wire here, and if it's too large, okay, it will blow the fuse. So the fuse is not usable after that. Okay, so fuse have different ratings, as you can see here. 6 ohms, 6 ampere, 10 ampere, 12 amperes. Depends on your use of the appliances, you will use the appropriate fuse. But take note that fuse has to be slightly higher than the current. Because if a lamp requires 4 ampere, you cannot just use a 4 ampere fuse, because at 4 ampere it's still functioning. So you have to use slightly higher, like 5 ampere. So it's okay. But don't use something that is too high. Okay, then you defeat the point of the fuse. Another issue is that because fuse have a standard ratings and they cannot specifically design a fuse, or it's not economic to design a fuse for your specific use at 4 ampere only. Okay, next thing, can remember the circuit drawing for closed switch, and then this is an open switch. Okay, so similarly, the switches are always placed on the live wire. 3-pin plug is very popular in Singapore because we follow the UK system. You have the earth wire that's connected to the earth. Then you have the live wire, which is the brown wire, connected to the fuse. Okay, and then you have the neutral wire. So the current flows from the live wire and out of the neutral wire. Earthing, this is the symbol. Okay, so earth wire is a low resistance wire that's connected to the metal casing. The metal casing, you can zoom in, you can see that the earth is connected to this metal casing. Okay. For appliances that doesn't have the 3-pin plug, so it doesn't have the earth, they have something else called the double insulation, and the symbol is 2 squares. Okay, so double insulation also prevents users from shock because the electrical cables are insulated from the internal components of the appliances, and also insulated from the outer casing. And that's the end of this chapter.